Very good afternoon to one and all present here. So today we can discuss this topic of parameters of multipath channel in wireless communication. In this topic, we are going to discuss about the various features as well as the parameters which are involved in the representation of wireless communication. So mainly the parameter power delay profile is used, which is nothing but an indication of the dispersion or distribution of the transmitter power over various parts of the multipath structure. So mainly all the multiple parameters, it is derived from the power delay profile. So what is power delay profile? It is nothing but the representation of the received power as a function of excess delay plotted against a fixed time delay reference. So the parameter types are, first one is time dispersion parameter, second one is coherence bandwidth, third one is Doppler spread and coherence time. The time dispersion parameters mainly focus on representing in terms of your mean excess delay, RMS delay spread, and the excess delay spread. So the first one is mean excess delay. This mean excess delay is the first moment or the first arrival of the power delay profile, and it is expressed as tau bar is equal to summation k p of ck by summation k p of ck. What is that p of ck represents? It is nothing but the power delay of your instant at each and every time instant, and ck is nothing but that particular received power. The second parameter RMS delay spread is the square root of the second central moment of the power delay profile, which is nothing but the standard deviation formula, which you have studied in mathematics. The third one should be the excess delay spread. So it is nothing but measured in with respect to the power level. In the previous two are in the terms of power delay profile, and this one is should be in the terms of power level. So what is this maximum excess delay? It is represented as the time delay during which multipath energy falls to h dB below the maximum level. So it is nothing but the difference between the first arriving signal, that is the tau RX, minus the maximum delay at which the multipath component is within h dB of the strongest arriving multipath signal. So this also defined as the temporal extent of the multipath, which will be above a particular threshold that the HDB level can be of minus 20 dB, and this should be the threshold level. And the second parameter is nothing but the coherence bandwidth. The coherence bandwidth is nothing but a statistical measure of the range of frequencies over which the channel can be considered to be flat. In this region, we can say that you have the response should be having equal gain as well as linear phase. It is nothing but a range of frequencies over which it has a strong correlation for amplitude level. So it is actually directly related to the RFS delay spread. So it is inversely proportional to each other. But mainly, even though it is inversely proportional, it depends on the correlation level. So if the bandwidth is over the frequency correlation of above 0.9, it should be equal to 1 by 50 sigma c. And if the correlation is above 0.5 and less than 0.9, then it should be 1 by 5 sigma c. And the next parameter is Doppler spread. This Doppler spread is and the coherence time are the two parameters which describes the time varying nature of the channel in a small scale region. So Doppler spread is related to your Doppler shift. So it is nothing but the range of frequencies over which the Doppler spectrum should be non-zero, and it should be related to Doppler shift as Fc minus Ft and Fc plus Ft. So that means we have the Doppler shift should be either positive or negative depending on which the motion of the particular user towards base station or away from base station. So thus the spectrum depends on Fd, which in turn depends on the velocity of the mobile and angle theta between the mobile and the scattered waves. So the maximum Doppler shift frequency is denoted as V by lambda cos theta, but your maximum value should be equal to cos theta is equal to 1. So the relation which is denoted that the angular value should be equal to cos 0 should be equal to 1. So the angular value should theta equal to 0 degree. So and the value should be nothing but your maximum Doppler frequency. The next parameter is coherence time. In this coherence time, the time duration over which the two received signals have a strong potential for an amplitude correlation. So it is nothing but the value which is inversely proportional to Doppler spread. So or we can say it is inversely proportional to the maximum Doppler frequency. So where Fm stands for the maximum Doppler frequency, it is nothing but equal to V by lambda, where V is the speed of the mobile and lambda is the wavelength of the radio signal. And this Tc is equal to 1 by Fm. It also related to the time correlation function. Even though it is inversely proportional to 1 by Fm, it is not always exactly equal to 1 by Fm. So it depends on the time correlation function. If it is above 0.5, then it is given by 9 by 16 pi Fm. And if that particular value is combined, we are taking geometric means by combining the first equation and the second equation. If you are taking geometric mean, the coherence time Dc is equal to root of 9 by 16 pi Fm into 1 by Fm. So it is nothing but root of 9 by 16 pi Fm square. So that value is approximately equal to 0.423 by Fm. This is about your parameters. The first parameter should be the time dispersion parameters. Under that you have mean excess delay, RMS delay spread, and the excess delay spread. And the second one should be the coherence bandwidth. And the third one should be the coherence time as well as the Doppler spread. Thank you.